This tutorial explains the basic work with the finite element method program. We will design a utility tunnel in homogeneous soil. We will start with the interface and input the shape of the terrain. If the terrain is flat, just input one point and the program will automatically design its shape. Now go to the mesh generation frame, press the generate button, and the mesh appears on the desktop. As you can see, the area is not deep enough, so go to the frame interface and press the button Ranges. Here, change the value of the deepest interface point to 15 meters. Now if you return into the mesh generation frame, you can see that the area of the analysis is deeper. The next step is to define the tunnel. For now, everything is done in the topology mode, while the construction stages will be introduced later. In the frame free points, we will now add points which will form the structure. It is possible to turn on the snap to grid function in settings as shown. This makes it easier to input the points using the mouse. Now we connect the points with free lines and create an arc on the top of the structure. Now generate the mesh again. As we see, the density of the mesh around the structure is not satisfying. This can be easily solved using line refinements. In the corresponding frame, select each line and input the radius and new length. When we generate the mesh once again, we can immediately see that the mesh is much denser around the structure, which is exactly what is needed. It is also necessary to define the soil, which is explained in detail in other tutorial, so we will skip this part. At this point, we have everything ready, so we can open the first construction stage and proceed to the analysis. In the first construction stage, we will calculate the static stress with all areas active. When the results are ready, add another construction stage where we will model the tunneling. In the frame activity, it is necessary to select that the area of the tunnel is inactive. And at the same time, the lining around the tunnel should be introduced. This can be done by adding beams around the tunnel. For this example, we will use a rectangular wall cross-section with 0.2 meter thickness. It is also necessary to input the properties of the concrete, which can be user-defined or selected from a defined catalog. We will use the C30/37 type concrete in this example. This needs to be done for all free lines, however the properties are saved in the dialog window, so this is a very simple process. When this is done, run the analysis again. We can now see that the stress has changed in the Z direction. We can also see the deformation of the structure or make the mesh visible. It is possible to store views. This is done in the visualization settings frame by clicking the Save button and naming the view. In the same frame, it is also possible to define which parts should be visualized and which not. We can, for example, turn on the visualization of the distribution of the bending moments. This view can also be stored, and as we see, switching between the saved views is really easy. In this example, we only used elastic solution, which is not enough when analyzing real structures. A real design requires introducing material models such as the Moore-Coulomb, the Ducker-Prager, or the Chem-Clay model, and also contact elements between the lining and the soil. Although real designs are more complicated, you can see that it is possible to make a model of structure using the FEM program in just a few minutes. More information can be found in other video tutorials, online help, engineering manuals, and verification manuals. Should you have any questions, please contact our support team.